Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is measuring the size of a vector. Before proceeding, make sure that you have already watched these other videos first. The size function measures how many items are in the vector. But if you're going to be comparing that against 0, it's more convenient to just use this empty function. This empty function also may be faster than size. This distance function measures the distance between two iterators. So that could also be used for measuring a vector's size by providing the iterators that are at the vector's inclusive beginning and its exclusive ending. Actually, this distance function works for any type of STL collection class because you could imagine its implementation only needing the ability to do the plus plus forward iterating operator, counting how many times that plus plus needs to be done to get from begin to end. STL's actual implementation will take a more optimized approach where possible. STL implements a vector as having some allocation capacity. In this example, STL allocates a capacity of 5 integers for the vector and then fills all 5 of them with values. When the programmer later requests insertion of 2 more items, STL automatically detects that there isn't enough space for 2 more. So STL allocates a new, larger buffer, this time having capacity for 10 integers. STL automatically copies the existing 5 items over into its new buffer, and then the 2 items can be inserted. When the programmer requests to insert 5 more, again, the desired size of 12 would be too big for the current capacity of 10, so STL does that reallocation once again, now making the capacity 16. When usage exceeds that 16, reallocation happens again. But this time, the size was 20 and the capacity was 28, so this requested insertion of 3 items can fit within the empty space without STL needing to reallocate anything. These capacities of 5, 10, 16, 28 are just examples. The capacities chosen by STL will actually vary from system to system. Most of the time, C++ programmers just ignore the capacity, leaving it as an implementation detail of STL, assuming that STL will make reasonable guesses about what the capacity ought to be, and knowing that STL will be able to do reallocation whenever its guesses were too small. But if you're optimizing your software, you might be able to make things faster by reducing how often STL needs to do these reallocations. You can ask STL to reserve upfront a larger capacity than it thought it otherwise would have allocated. And then you can more quickly do all of these size growing operations all within that one allocation. If STL has already allocated as many items as you ask for, then the reserve function does nothing. If you remove a lot of items from a vector, then its size will be much less than its capacity. Then STL doesn't normally make any adjustment. Instead, there's just a lot of empty memory waiting around for some future items to be inserted into the vector. If you know that you won't be inserting many other items into it, then you could instruct STL to reallocate this collection back into a smaller capacity that matches its current needs. Use the shrink to fit function to make that instruction. If a sequence collection is being indexed by integers, then the max size query function is similar to asking the system what is the largest integer that can be represented. However, this max size may return something that's smaller than that for some other platform-specific reasons, such as limitations that come from the memory system. We normally program size and empty as member functions of the vector, but you could instead program them as global functions. This sometimes might be useful when you're programming inside of a template.